All right, let's open the file on one of the biggest, most misunderstood problems in AI today, hallucinations. And this isn't some academic quirk, it's a hidden crisis and it has some very, very real consequences.
What kind of consequences are we talking about? Well, let's start with a number. $67.4 billion. That's the estimated loss for businesses around the globe from AI hallucinations in just a single year. It's a staggering figure, right? And it's all driven by bad decisions made on faulty information that looked perfectly correct.
So how often is this actually happening? Well, get this. According to one test, this is the hallucination rate for a top-tier AI model when you specifically ask it questions it doesn't know the answer to. Instead of just saying, I don't know, it makes something up nearly 9 times out of 10.
But okay, here's the crucial context. Because that 88% is a stress test. This 30% figure, this is a much more realistic scenario. In a normal conversation, even the top model with full access to the web still hallucinates almost a third of the time. Just think about that for a second. 1 in every 3 complex answers you get could be subtly or majorly wrong.
And then there's this bombshell. One really popular model, Grok 3, was tested on how well it cited its sources for news stories. The result? It got its citations wrong an astonishing 94% of the time. The links might even go to real websites, but the information it claims is on those pages, often it's pure fiction.
So, let's dig in. How do these individual errors snowball into a multi-billion-dollar problem? It's not just about getting a wrong answer. It's about the massive, real-world cost of trusting AI without verifying.
And the costs are just wild when you break them down. First, you've got nearly half of all executives admitting they make major company decisions based on AI content they haven't even checked. Then you've got the time cost. Employees are spending over 4 hours a week, that's half a day, just double-checking what their AI assistants are telling them. That adds up to over $14,000 per employee per year, just wasted. And it's not just a business problem. This is a full-blown credibility crisis. I mean, even top academic conferences have been duped, accepting dozens of papers with completely fake AI-generated citations.
This all leads to the big question, right? Why? Why does this even happen? So, let's investigate the culprit and figure out exactly how these incredibly smart systems can produce such confident nonsense.
First, let's get a really clear definition. An AI hallucination is when a model just invents information out of thin air and presents it to you as stone-cold fact. It doesn't hesitate, it doesn't show uncertainty, it'll give you a completely fabricated legal case with the exact same confidence it uses to tell you that 2 + 2 is 4. And because the language is so fluent and perfect, it's incredibly hard to spot.
And this is where it gets really weird. Researchers have found something they call the confidence paradox. They discovered that AI models are actually 34% more likely to use confident-sounding language, words like certainly, definitely, without a doubt, at the exact moment they are wrong. The more incorrect the information, the more sure of itself the AI sounds. It's unsettling.
And here it is. This is the fundamental reason why this all happens. You have to remember, AI models are not databases of facts. They are unbelievably sophisticated prediction engines. Their one and only job is to predict the next most statistically plausible word to come next in a sentence. They don't know truth, they only know what sounds right. It's kind of like an improv actor who forgets their line. Instead of stopping the show, they just invent something that sounds like it fits the scene.
Okay, so this is where things get really confusing for anyone trying to keep track of this problem. You'll see one headline that says a model is great and another that says it's terrible. So let's unravel this key piece of evidence, the benchmarks themselves.
And here's the big aha moment. It turns out different tests are measuring completely different things. You have the Vectara benchmark, which basically asks an AI to summarize a document. It's a test of faithfulness. Did the AI add anything that wasn't in the original text? But then you have AA-Omniscience, which asks the AI really hard questions. It's not testing faithfulness, it's testing intellectual honesty. Does the AI admit when it doesn't know something, or does it just guess?
This whole conflict becomes crystal clear when you look at one model's scores. On that summarization test, it scores an excellent 2.1% hallucination rate. Looks amazing. But on a citation accuracy test, that rate skyrockets to a catastrophic 94%. This is proof positive that a model's hallucination rate isn't one single number. It completely depends on what you're asking it to do.
So, keeping that in mind, let's profile the major players in our little investigation here. Each of these models has a really distinct personality when it comes to being truthful, and understanding their different trade-offs is absolutely key.
The choice between Claude and Gemini, for example, really boils down to this one core trade-off. Claude is designed to be more honest. On that intellectual honesty test, it scored a perfect 0% hallucination rate. Why? Because it just refused to guess. Gemini, on the other hand, knows more stuff, but it will fabricate aggressively to fill in the gaps. Even the best version of it still guesses wrong about half the time on that same test. So the choice is yours. Do you want a wider breadth of knowledge that you have to verify, or a deeper sense of trust for situations where a wrong answer is just too costly?
Now, what about the GPT models? Well, the data shows that the single biggest thing you can do to fight their hallucinations isn't upgrading the model. It's just turning on web access. I mean, look at this chart. One test showed a model's hallucination rate plummeting from a crazy 47% all the way down to under 10%, just by letting it browse the web. That is an 80% reduction from flipping one simple switch.
So we've looked at the costs, the causes, and the key players. But this all brings us to the final verdict of our investigation. And it starts with a real bombshell about the very nature of this problem.
Let's be perfectly clear about this. Getting to zero hallucinations isn't just a really hard engineering challenge. Researchers have now proven that with the way these models are currently built, it is mathematically impossible. This is not a bug that's going to be patched out in the next update. It's a fundamental limitation of the technology.
And there are two main reasons for this. The first is architectural. An engine that is built from the ground up to find the most probable next word will, sometimes, by mathematical necessity, prioritize sounding good over being right. The second reason is a fundamental goal conflict. Think of it like a genie's wish. You can ask an AI to be truthful, to be comprehensive, and to be honest about its limits. But the math shows you can't have all of those things at once. You can pick 3, but you can never have all 4. One of those goals always has to give.
Okay, so if the problem is impossible to solve completely, what on earth are we supposed to do? Well, we have to shift our thinking. We stop looking for a perfect model, and we start building a smart process. This is the toolkit for managing a risk that we know is never going away.
So here's what the data shows actually works, ranked by how big of an impact it has. Tier 1 is your biggest win, by far. This is stuff like turning on web search, which we already talked about, and using a technique called RAG. RAG basically forces the AI to base its answers on specific documents you give it. These two things alone can cut hallucinations by over 70%. Tiers 2 and 3 give you even more reduction through things like cross-checking one AI's answer with another and using really careful specialized prompts. The takeaway is clear. Tackle the biggest factors first.
Which brings us to the very end of our investigation. After digging through all of this data, all the benchmarks, and even the mathematical proofs, it becomes so clear that we've been asking the wrong question this whole time. See, the right question isn't which AI is perfect, because as we've just seen, none of them are, and none of them ever will be. The only question that really matters now is this. Since we know hallucinations are a permanent feature, not a temporary bug, what is your process to catch them? Because in the age of AI, it turns out the most important intelligence is still our own.